Hello, everybody, and welcome to Sparring Partners. This is Monica Paolini from Sansafili, and I'm your host today. And I have the pleasure to have with me today Upendra Pingle. He's the SVP in Intelligent Cellular Networks at CommScope. And he has been there for quite some time, working on different things. And today, we're going to talk about DAS in the context of indoor coverage, but also in terms of how DAS has evolved. You know, DAS has been, it's very, it's mostly common, I would say, in the US. In other countries, like in Europe, there is a little bit of suspicion about DAS, or it's viewed as a legacy thing. And what we're going to talk about today is how DAS has evolved, is evolving, and how should we think about DAS for indoor coverage when we relate it to small cells and Open RAN. But I don't want to spoil it. So let's first, Upendra, why don't you tell us who you are and what is that you work on your daily work job?
Good morning, Monica. Thank you very much for having me on your podcast. I'm responsible for the indoor cellular coverage in CommScope. And from a product line point of view, that means products like DAS, repeaters, indoor small cells. From an application point of view, it means both public networks as well as private networks. And you're right, it's an interesting topic to talk about. We have come a long way in terms of the evolution of these technologies over the last several decades. And as we are deploying solutions in 5G, and as we start thinking about specifications of 6G, I think this is a very important topic to talk about. So thank you for having me on the call.
Absolutely. And it really is. And people do not talk a lot recently about DAS. And in fact, people don't talk enough, in my view, about indoor coverage either, which is really a major thing because most of the traffic comes from indoor locations, like 80+%, depending on who you talk to and where you are. So it's not a detail, indoor coverage, indoor connectivity. But we don't talk as much as we do for outdoors, which I think is like, doesn't make any sense, but nevertheless, that's the way it is. So why don't you give us sort of an overview of DAS? Why is that we're still talking about DAS, which is something that I think a lot of people would ask, DAS, what do we need it for? We have small cells, we have Open RAN, what do we need DAS?
Great question. So let me just start by kind of expanding on your comment earlier that typically, if you think about the RAN, the network, cellular network, most of the times the discussion goes around outdoor macro, the high power outdoor coverage, because when the operator buys the spectrum, they have an obligation to cover the certain areas, right? So typically, when you think about cellular coverage, when you talk about ORAN, normally it's all gets associated with outdoor macro. Having said that, you bring up a great point. Most of us are spending most of the time indoor. All the data consumption, 70-80% of that is happening indoor. And most importantly, as we are migrating from 4G to 5G to 6G, and as these bands are going higher and higher, as the spectrum is going higher and higher, the outdoor in strategy just does not work, because as the frequency goes higher, it has a hard time penetrating buildings like concrete and glass. So you absolutely need a dedicated system to cover all the coverage and capacity requirements of a venue such as a large stadium, a campus, a college campus, a hospital, or an enterprise building like retail stores. Doesn't matter. Any indoor coverage and capacity requirements, you need a dedicated solution so that your requirements are satisfied and you can put a lot of applications. And if you start thinking about stadiums and enterprises, a lot of new applications are coming in that I'll talk about more in detail. You absolutely need a high quality, good indoor cellular coverage solution. And that is exactly what we do. Now, to your question, if I really roll the clock back decades, because we've been in this business for multiple decades, Back in time, the indoor coverage started as outdoor in. So whatever signal you are getting outdoor, there was like a best effort use case that if that signal comes inside the building, you use it. And if it doesn't, then well, good luck. It started from there. Then it started evolving to a point where people are like, no, I need to take that signal and distribute inside the venue campus building. So the concept of repeaters came in. So you took the outdoor signal and then you repeated it and then you distributed it throughout the building, venue, campus. Then obviously people realize, well, that's not going to cut it for too long. So then the concept of a distributed antenna systems came along. And back in the day, we had an analog distributed antenna solution. So it's a more sophisticated way of repeating and distributing the signal than a traditional repeater. And then CommScope migrated to digital DAS. It's about 15 years back. So we went from the traditional analog DAS to more sophisticated digital DAS, and thereby driving the need for cabling and bulky equipment down and having a way more sophisticated system out there. Once we had the digital DAS, we came up with the concept of taking that digital DAS and connecting it directly through an optical source to an OEM's baseband in the 4G days. So thereby eliminating all the big and bulkiness of a traditional DAS. And now as we are in 5G, we took the concept even further by developing an ORAN-based DAS, which connects directly, digitally, to an ODU from any OEM, and then thereby eliminating all the bulkiness of the radios. So you have this evolution of a traditional system that is evolved into something extremely sophisticated. And now if you start thinking about indoor small cells, you can almost say that, you know what, this sophisticated indoor DAS system is almost like a small cell, with a big exception that it's higher power than a traditional indoor small cell, and it's multi-operator. I mean, I can say that an indoor small cell can be a single operator, dual operator, multi-operator. A DAS system traditionally has been multi-operator, and it can go low, medium, high power depending on the use case. So we've just evolved this concept of DAS into a very sophisticated system that when I look at our system right now, an ORAN-based digital distributed antenna solution is hardly a traditional DAS that we used to see like 20, 30 years back. So it's a very evolved, sophisticated digital ORAN-based system that we have in place now.
This is really interesting because, you know, traditionally not only DAS was big, but also difficult to manage, expensive, so only few venues could use it. So now it's still mostly for big venues, but the cost and the complexity is reduced along with anything. So that makes it much more appealing. And the Open RAN component, the multi-vendor component, I guess that's, you know, that obviously adds to the attractiveness, and, you know, the fact that you can share it or not share it, you know, that adds. But I guess it's the multi-vendor component is quite important. I think it's really interesting because it expands the concept of Open RAN, which is something I've been talking a lot, that, you know, we shouldn't be thinking about Open RAN as the you know, traditional, I mean, the sort of simple way. There are multiple ways to do RAN, and there are multiple ways to open it. So the Open RAN concept is more than just having CU and GU separate of a different vendor. There's more to that. And so I think it's a really interesting, so when your announcement of doing the multi-vendor DAS, open DAS, I guess, is it an open DAS? With Verizon, the question that I got from the press was, is it really Open RAN? I mean, and yes, why not? But I guess there is that question. So if I were to ask you that question, is the Open DAS or the DAS Open RAN really Open RAN? I mean, how would you answer that?
Okay, great question. So let me just use the example of the Verizon announcement that came out a couple of months back. And we are very excited, very happy to be part of that. Very fortunate to work with Verizon on that and with Samsung. So what Verizon announced was that in the US, they deployed the first multi-vendor Open RAN system with Samsung DU and CommScope's ORAN DAS. And if you just think about the concept behind that, essentially what that means is CommScope Open RAN DAS is almost like an ORU in the context of 5G ORAN, right? So it's CommScope ORU connecting with the Samsung ODU, and then you go for the deployment. So from a Verizon perspective, they've already approved Samsung as their ORAN partner, and we are hooking up to that. So if you think about the 2, 3 pillars about ORAN, uh, one is multi-vendor usability and thereby driving innovation. So you can mix and match different components and get the best out of everything that comes from the innovation. So that's the piece that we implemented there. The second piece in terms of ORAN could be virtualization. The third piece could be standard cost servers, right? And before I get completely consumed by the technological discussion, let me just go on the other side and start thinking from a customer perspective. There are multiple customer bases that we serve, right? If you think about where does an in-building cellular solution go? It goes to operators, it goes to enterprises, it goes to the neutral host, and obviously the venue or the building is the consumer of it, essentially. And depending on which perspective you take, you have different benefits that you can get, or you have different requirements. From an operator point of view that we just talked about, the main benefit that they'll get is the best in class innovative solution from each of the pieces. They get the best from an ODU and they get the best from an ORU. From a venue perspective, from a stadium perspective, let's say, what they get is the space savings and electricity savings. And we have talked about this on your last podcast also, Monica. The fact that CommScope's digital DAS allows us to connect directly optically to the ODU or an ORAN based solution from some other OEM, thereby eliminating these big bulky radios. It's a massive space savings for stadiums. And then because you don't need these power hungry radios to power up first and then cool them down, you have a massive savings in terms of electricity. So if you're a venue owner, if you're a stadium owner where you have this massive need for coverage and capacity, you need hundreds, if not thousands of radios to power up cellular solution in a stadium. Well, you just got a bunch of space back to you because you don't need the space to put those radios. And you just cut down your electricity bill because you don't need to power up those radios and cool them down. Now, what you can do with that space is you can monetize that space. You can put concession stand. You can figure out how to use that space in a nice real estate that they're putting that in and monetize that space. And obviously, the energy savings, they can get the credit for the energy savings, not to mention the OPEX savings and the dollar savings. If you think from an enterprise perspective, they may not care about all this technology and ORAN and this and that. And for a small or medium building, the space and electricity savings may not be as much because you just don't need those many radios. But what they are used to is the simplicity of a Wi-Fi system. So what enterprise looks for is not the technology necessarily, not the mix and match necessarily. What they're going to look for is ease of X. If I can give them a solution that is easy to deploy, easy to maintain, that gives them end-to-end visibility, and is deployed on standard cost servers, just like a Wi-Fi system, now they will get more comfortable, more familiar with the solution, and they are now going to go deploy more cellular systems as opposed to just depending on Wi-Fi. And of course, Wi-Fi will have its own space always, but now they can put different applications on Wi-Fi and different applications on cellular. So if you put yourself in from a customer perspective, you're going to get different benefits depending on who you are, a neutral host or a venue or an enterprise or an operator. And the best part of this is because we have a solution now, an ORAN based DAS or ORAN based, I don't even want to call it DAS. It's too sophisticated compared to a traditional DAS. Because CommScope now has an ORAN based indoor solution that can cater to operators, enterprises, venues, and neutral hosts alike, we can do it all. We can go up vertically and we can go up horizontally, depending on what the application is. So very excited to be about this.
Yeah, and I think that, the issue of the flexibility and the need to uh, the need to basically talk, well, have meet the needs of different type of people, different type of people in the value chain is really important. And I think that that's really something that so far, when you talk about private networks, that's where we have been as an industry missing, because it's either too complex for the enterprise, but there's always, it's sort of the technology works, but the pieces together are kind of not quite there yet for various reasons in different parts. So the growth has not been as quick as we wish, or as quick as the technology will allow us to do. So, so this is quite interesting. But maybe you can tell us a little bit about how hard it was to actually do, because a lot of the Open RAN deployments are actually single vendor, which I still think it's a good thing and it's still valuable. Don't get me wrong on that. But this was, different vendors. How hard was it to get it to work?
Yeah. So I would say it was a mixed bag. First of all, to do something on ORAN obviously is new. It's new for the world. To do something on a multi-vendor ORAN, as opposed to just connecting with your own DU, is definitely challenging because the requirements are different. And as you know, ORAN is not a static spec. ORAN, there are layers in ORAN, vertical layers, horizontal layers. So depending on the implementation of that system, depending on if it's for FDD, for TDD, for US, for Europe, various aspects to it, as opposed to just saying, oh, am I ORAN compatible? Yes. I mean, there are layers to ORAN compatibility. So that was I wouldn't say challenge, but that was a huge learning for us. And we've been at it for a long time. And again, this is an evolving thing. So we are going to continue designing, we are going to have to continue investing in this space, because we are just taking the first step right now. And it's a long journey that we are going to go forward in the next decade or so. But we have been at it for a while now, right? It's taken us a long time to get to a point where we can truly get into our digital dash or our ORU, let's say, to work with somebody else's ODU, right? So it's a long journey. Having said that, what made it relatively straightforward for us is because if you look at our digital dash in 4G space, we had the optical connectivity directly to another OEM's baseband. So conceptually, we know that we can actually take two disparate systems and connect them optically and make that work. Now, obviously, ORAN brings a new learning, new challenge to the place that we had to work through. So it was not like a 2-month project. It's been going on for a few years, let's say. And the good thing about that is now we understand what it entails to come up with a brand new open architecture solution. Now that we have the foundation of it, we just have to make sure that we build on it and we come up with a solution that applies to any OEM, for any operator, for any region, for any implementation, and for any use case, as in public networks or private networks. So this is a massive, huge journey that we are going to go through for next decade, if not longer, to make sure that all our solutions are ORAN compatible in those spaces, in geographies, in OEMs, in operators, and in applications.
So if you were to say, what is that you learned that you were not expecting? I knew that, I mean, I would imagine that as you got into it, you thought, oh my God, this is just going to require a lot of work. You knew that. But if you were something that you did not expect, that you say, I didn't think about that. What was there something like that?
I would say, going back to the comment I made earlier about the implementation of the ORAN, it's unique. So even when you are ORAN compliant, the implementation of that is unique, and that's I would say the learning that we have, and in a way that is helping us understand as we go forward with more ORAN implementations on our product, how do we tackle that? Because one OEM's ORAN implementation with a particular operator with a particular region may or may not be the exact same of even the same OEM's implementation with a different operator in a different region, right? So if you think about it, this is going to be a journey for everyone to go through for next several years as to how do you take the foundational implementation of ORAN, which is what we are working on right now, and customize it in a way so that it can cater to any implementation depending on the OEM, operator, geography, and application. That is exactly what we are working on, and it's a big investment that we need to put in uh, to make it work, so that we can get to a point where our products works with anything, anywhere, in any application.
Yeah, but I guess, I mean, I remember being involved into the initial certification, I mean, interoperability in Wi-Fi, which at that time was new. And at the very beginning, it would take forever to do anything, right? I mean, and now it's like a matter of, a day or whatever, it's like standard. But there has been so much work and so many like, should we do this, should we do that? And eventually it worked, but clearly there is a big learning process. So it's good that you acknowledge that. I think it's very important because sometimes it's just like, oh, that's just you just need to do interoperability, and it's like, no, 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 no. There's actually more than just making sure that A and B somewhat work together. They have to work well together, right?
That's
So
exactly right.
okay, now let's move a little bit, further. So, okay, so you have DAS and you have the Open RAN sort of architecture that allows you to disaggregate. But the other thing is that, in a way, DAS is being evolved towards looking more like a small cell, and especially with Open RAN, a small cell looks increasingly like DAS-like, right? So will at some point the difference disappear, or has it already, or how do you distinguish the two?
Great question. You're right, especially when you look at, I mentioned to you about the sophisticated system that we are working on, a digital DAS with direct connectivity with an open architecture. The lines between a DAS or the sophisticated DAS and an indoor open RAN small cell, let's say, are very blurry. And then you can start thinking about, so what is the difference between a DAS and an indoor small cell? Well, there are two, three ways we can look at it. One is purely from an application point of view. If you look at an application that's in large public venues, uh, stadiums, airports, train stations, where multi-operator connectivity is an essential. I mean, that's like the price of entry, where different power levels, low, medium, high, depending on what you're trying to coverage and give capacity towards, then the DAS system is the solution. But if you think about an application inside an enterprise, a small enterprise, that may be okay with one or two operators, if not all operators, but in some cases they want multi-operator. For example, if you're going in a hospital, you might be okay for all the staff, the doctors and nurses, to be on just one operator, and you can deploy a single operator indoor small cell. But if you expand that application and say, no, I want to be able to cover not only my staff, but all the patients that are coming in, all the equipment, remote surgery is going on, then you may want to have not only a multi-operator system, but obviously a slice taken out to be able to do those things and connect machines as opposed to just people. So you can think about the difference between DAS and small cell from an application point of view. If it's a medium or a large venue or campus, you can say it's a DAS solution. If it's a smaller building, a single or dual operator, you can call it indoor small cell. The other thing you can think about, Monica, is the power level. DAS, because it's a solution that covers multiple applications. I mean, if you think about a stadium, we are deploying a lot of stadiums now with a common head end, with fiber feeding the stadium itself, few hotels right next to the stadium, few gaming stations in the vicinity. So one application, one head end is serving all those use cases. And then depending on the use case, you may need a low, medium, high power type of radio. Whereas in small cell, if you're covering a small building, you may be just fine with a low power type of application. So that could be, so one is application, one is the level of power. Third is, like I said, a DAS will definitely go with a multi-operator solution because you're trying to cover mainly a public area and you want to be able to give all the three or four operators in the country service to the public. Small cell may not be as such. And especially back to your comment, Monica, earlier, if you're really thinking about an indoor small cell in an enterprise for private networks, you may not be even thinking about people at that point in time. You may be just thinking about IoT. You may be just thinking about this example that I mentioned in hospitals. You may be fine with Wi-Fi for a lot of things, and you may want to just put cellular for things that need high capacity, high device connectivity, high security requirements. You may just want to put all those applications on a private network with an indoor small cell. So those are some of the differentiations that we think about. And then one obvious one that I left out is when you look at a sophisticated system indoor solution, maybe the difference between DAS and small cell is just a simple fact as to whose signal source you're using. If it's your own signal source, then you can call it small cell. If it's a third party signal source like a OEM 123, you can argue that it's a DAS solution. So there are different ways you can slice it, but they all come to the same point that you made earlier, that technologically we have come so far away that there is a very thin line now between a indoor small cell and a traditional DAS.
Yeah, and that's actually quite interesting because in general in the industry we have been talking less about small cells. I mean, just as a terminology issue, right? And more about indoor coverage, and actually I would say more about private networks. So it's private versus public. But then, as you say, there is a lot of indoor that is actually public, like in a
Yep,
stadium or an airport, or that it's partly public. It's both, it's a hybrid. So I think that, the more you think about it, so you need indoor coverage and you need a special infrastructure for that. But the way you can get to it is going to be very different depending on your needs. And no matter what your needs are, having an open architecture, it's helpful anyway because it gives you more flexibility. So I guess what I'm extracting from all you're saying is that, we should just think about what is that we need to do in terms of coverage, where is that we're going to go, what's the physical infrastructure, the physical buildings, and then find what's the best solution. And there's a lot of them, right? So
that's exactly right.
it's like pick whatever makes it compelling for everybody because who's paying, and depending on who is paying, you might just say, well, this or that is going to be better.
That's exactly right. I mean, our view is customer first, user first, consumer first. And if you
Mhm.
think from that point of view, all these other things in terms of the technology implementation and innovation will just follow that rule. Because I just use my own example. I have a gigabit fiber at home
Mhm.
for my broadband, for my home Wi-Fi. When was the last time I really tried to dig in to understand? Well, because I'm in this field, I will. But as just a general consumer, do I care about the box that's in there, the router that is giving me how fancy that router is, or what color, even what color is it? In fact, I don't even want to look at that router. I may just want to hide it somewhere. All
Yes.
I want is a good coverage and capacity throughout my house and then maybe in my front yard, backyard. All I want is a very easy app on my phone that I can do some basic remote troubleshooting and this and that. And I want a competitive price. That's it. And I'm just thinking if I look at my home broadband as that as a consumer, why do I expect my customer to think fundamentally differently? They want the benefits in terms of usability, ease of use. They want the benefits in terms of competitive pricing. They want the benefits in terms of space and energy savings. And they want some kind of an application, some kind of a management layer that makes it easy to monitor and and consume. That's it. If you think from that point of view, all these other things from technology point of view just start aligning towards that goal. And if I go back to our previous conversation about ORAN, that is what ORAN is actually allowing you to do, right? It's allowing you to save the space, energy, ease of use, full visibility, standard service. So it's just a means to get to the end. That's all we are looking at.
Yeah, so let me link back to a couple of previous podcasts. So there was the one we gotta go to know at Verizon that talks about the DAS that they did with you at Verizon. So for everybody listening, you can just go and listen to that to get more detail and the Verizon perspective on that. But I also just recorded a podcast with Dean Budley, and we talked about private networks, indoor coverage, and one of the issues that came up is that clearly, we want to see more, that there is a clear need for more indoor coverage because of the reasons we talked about before. But at the same time, when you look at like 3GPP, for instance, the focus there is more on public network and outdoor coverage. And that's well, it's partly because of historical reasons and partly because of those who are participating in it that are more focused on public wide area networks. Do you think that 3GPP, and especially as we move to 6G, is doing all it needs to do to get to facilitate the indoor coverage, to facilitate the kind of vision you have of, having all this flexibility? Is 3GPP doing enough work for that?
Yeah, so if I start thinking from two perspectives that we are entering more and more into, one is the definition of spec for 6G as we go along, and second is enterprise funding their own needs for cellular coverage. And I think these two are going to converge, and the convergence point could be private networks. And back in the day, I would say a few years back, Monica, when we talked about private networks, we were all consumed by private networks on a shared spectrum,
Mhm.
CBRS in the US or band 77, 78 outside of US. But now you start realizing that, well, the license spectrum from the operators is going to be a huge consumer of the private network, right? And that's why a lot of these discussions around slicing are coming in place, right? Because you don't need necessarily a shared spectrum to deploy a private network. You can just take out a slice of a public network and you can have that just dedicated for certain applications. It could be private networks or it could be whatever specific applications. So I tend to agree that as these specs are evolving and as we start seeing more and more slicing requirements, it's going to pave way for taking that requirement and being able to deploy in 6G, in private networks, in enterprises. So I do believe that we are moving in the right direction. Uh, from a go-to-market point of view, I think things have to get more easy for enterprises, right? Because they're used to Wi-Fi. I mean, that's the level of simplicity enterprises are used to. How do we make sure as an ecosystem between the large OEMs, between operators, between the specing agencies, standardization bodies, how do we make sure that we make it easy for enterprises to be able to buy and consume cellular network? You made a very interesting point earlier that for a variety of reasons, private networks has not picked up, right? And you're right. Indeed, there is like a variety of reasons. One of the reasons from my perspective being it's not as easy for enterprises as it is for Wi-Fi to be able to put design, deploy, and use a cellular system. So as an ecosystem, if we all believe that wireless and cellular is the fourth utility, then we need to make it easier to get the fourth utility. We can't say that, okay, water, electricity, and gas comes in pretty easy, but then cellular coverage takes time. Enterprises need to believe that the solution is easy, is competitive, and they can get that fast. So I think we are evolving as an industry to get there. But again, we all have a piece to play to make sure that we make it easy for enterprises almost to a point of easiness like Wi-Fi so that they can go deploy that way more. Once that happens, we can debate about public or private, private on shared spectrum or a licensed spectrum with a slice. Those are details that we can work out. But once the consumption starts getting easier, and I use this, I mean, we all talk about ease of X, ease of everything. I mean, when we say ease of X, ease of getting that service, ease of deploying that service, ease of maintaining that service, all that needs to get easier. just like Wi-Fi, for this ecosystem to evolve and grow. And we are going to contribute to that. We are obviously driving from a technology point of view for all the things that we talked about earlier, and we are going to make sure that we continue progressing our journey to make it easier for enterprises to talk to us, buy our product, and deploy our product so that they can get the cellular coverage inside.
Yeah, and I think that actually there's not enough that you can ever say about, the simplicity. It's really crucial because whenever you talk to any enterprise, they will say, yeah, that sounds very cool. All very cool. They like, and they do try, there is no question. No, I've never heard any enterprise that would say, oh, we don't care. That's not, I never got that answer. But there is always a question of how complicated it is. Can we do it? And so what happens is that the enterprise would only do it when they are in a situation where they couldn't do otherwise. And actually, to some extent, it's the same with operators. They will go into indoor when they cannot do it with the macro, which sort of makes sense. You use whatever you're used to until you cannot anymore. It's just like obviously you do that. So
Yeah.
you need to make it so simple that the step is not as painful as it is. Because I don't believe that cost is an issue as much for the enterprise. I mean, I'm not saying that it doesn't matter, but the cost that whenever you talk to the cost doesn't come up as the stop. It's like, oh, this is so complicated. It needs to take time. I need to do testing, I need to do that. And is it really? Do I really need to? Can I postpone it?
Yeah.
Yeah,
Yeah.
and we need to get out of that kind of loop.
That's exactly right. And cost is not necessarily an issue, because end of the day, if you're going to go in a subscription model, and
Mhm.
that subscription model allows you to get rid of any headache
Yeah,
of buying, deploying, maintaining that service, which is what I do as a consumer on my home broadband. I just pay a
exactly.
monthly fee, and I don't care about anything else. Everything else is done for me in that monthly fee. So I'm happy. So as long as the price is competitive, you're right, cost is not an issue. It's the ease of X that we need to help enterprises to get to that point.
Yeah, absolutely. Okay, our time is up, but Upendra, it was great as always talking to you. It's always like great vision on the evolution of the brand. So thank you so much for sharing that with us today.
Thank you very much, Monica. Talk to you next time.
And thank you all for listening in. And if you liked this podcast, subscribe to the channel and listen to the other ones as well. Thank you so much.